talk about the notation in R. This is a super, super useful video, and I think if you learn R the right way, if you want to learn R the right way, I think there's a lot of benefit that you will derive later on. Okay, so with that, here are the learning goals for this lab. We will learn how to select values from a data frame using R's notation or indexing notations. We will be using alternate forms of indexing as well, which we'll get into later, including dollar signs and double brackets. So dollar signs, exactly this, and double brackets, which are basically your square brackets. So let's start with the first type of indexing we learn about, which is on selecting values. So let's go over the basics here. We will be working with a data set called MPG. It stands for miles per gallon. It is a data set on cars and their fuel economy that's given out by the Environmental Protection Agency, the EPA, and it's made available on this website. Okay, and now this is preloaded into your base R, and it contains models of cars which had new releases every year between the years 1999 and 2008. And this was used as a proxy for the popularity of the car, right? So if you have models that are released every year, then it speaks to the popularity of the car. So let's go to R for a second and come back here. Okay, so we'll go back to R, and here's R, and I've just opened up a script. If you don't know how to do that yet, you have to go back to the older videos, but here's a script. And what we're going to do is the first thing we want to do is install .packages, and we will install the ggplot2 package. Okay, so you can go ahead and run that, and it says, do you want to install this? Go ahead and install this, and then we want to load this package as well. So we are, sorry, I don't want to be in my console, but I'll stay here in my script, so you can always save it later. This is just good for practice. And you can see as soon as I say library, it shows me all of the available packages. So I'm gonna write GG, and then it just tells me ggplot2, right? So I want to make sure I run this command, and so in the console you can see that that's run. Okay, and then subsequently I want to load the data. So the way to load the data is you just say data, and then you have all of these preloaded data sets that come in the ggplot2, that are included in the ggplot2 package. And notice MPG is one of those. So we are going to click on that, and then notice that this is in quotes. And when we run that, it tells us that this has 234 observations of 11 variables. You might even want to look at this, so you can always click on it and you can see what this is. So this gives us information on the car manufacturer, the model of the car, the displacement, year, the number of cylinders, transmission, what type of drive it is, the city and highway mileage, etc., right? And then the class. So you can always look at what these mean by typing in help MPG, and notice on the right hand side you can see that there's a description of the data set, and then it also tells you which package it's coming from, and also it gives you the different types of variables that are in this data set along with their descriptions. Okay, so drive refers to the type of drive train, where F represents front wheel drive, and then R would represent rear wheel drive, and then 4 represents 4-wheel drive. So you see data comes in different types of formats, and that's what we want to keep in mind. So clearly, if drive, for example, this column right here is taking a value of F or R or 4, you can see that it's sort of a mix of your character objects and your numeric objects, right? So R would always interpret that as a character, but we can always see that by typing in str and typing in mpg, right? So when we do that, notice that drive is a character vector, even though that includes the number 4, right? And you should know that by now, given that you watched the previous video. Okay, so that's what this is, and you can see that the data set has 234 rows and 11 columns, and each column has a name, which is going to be very useful for us later on. So this is these are the names. Manufacturer is one of the column names, model is another, and so on and so forth, all the way up to class, and these are all 11 different variables, right, that are represented in columns. So whenever you use the, let's take a look here. Whenever we use the structure command, the output that's delivered in R is given to us in this way, where after the $sign, you're going to see the column names. So even though these are represented as rows, these are not rows, these are columns, but this is just for compactness that R throws out these types of, this type of output. But you can see here that this is giving you the dimension of your data frame, which is 234 rows times columns, so 11 columns. Okay, so that's what we want to know for now. And then we'll go back to our lab, okay? So let's go into full screen mode. So this is our data. That's what we did. We just want to make sure that we have the correct packages installed, and then we load the data set and we take a look at it. Taking a look at it is very, very important because it does tell you the type, or sorry, the class of each variable or each column in your data set, and it tells us how many observations do we have, and it sort of lets you glance at what these variables look like. Okay, so that's what that data looks like, and let's talk about how do we extract values. So if we wanted to extract a value or a set of values from a data frame like MPG, we can use a pair of hard brackets or square brackets in this way. Okay, so we're going to put something in, we'll talk about that, but it is generally going to be separated by a comma. Okay, so separated by a comma, as you can see here. And then usually what we give first, right? So right after you start this bracket, the first index will be pointing to the subset of the rows that we want to extract from the data frame, and the second index, which comes after the comma, the second index is going to be used to subset the column. So it's best that we talk about an example here. So let's take a look at this first example. It says, let's see what type of code should we write if we want to extract the value from the first row and the first column. So all you have to do is simply write down MPG, open up your square brackets, and because we want to extract the first row, we write the number 1 followed by a comma, and then we extract the first column. Okay, so this is, in this way, we are basically going to get the first, we've extracted the first value from the first row and first column, right? So if we go back to our data, we can even check this. The first column is of the variable manufacturer, and the first row in that is an Audi, right? So we can say, we can see that how that works, okay? But it's possible that we want to extract more than just one value. So it's possible that we want to extract a set of values from this data frame. And so here is a command in R that would, let's see what this would do, right? So here, remember the first index before the comma is referring to the rows that you want to extract, right? So this is saying this is a vector We want to extract all the rows from number 20 to number 22, right? So the 20th row to the 22nd row will be extracted. And then we also are specifying the columns here. So after the comma, notice after the comma, we are writing another vector, which is saying that extract the columns 1 and 2. So let's say we want to go back to the data here. The first two columns are manufacturer and model, right? So if we know that, then we can test this out and we can see that manufacturer and model are returned. And what we have is a 3x2 data frame, okay? And which has 3 rows, right? 20, 21, and 22, and 2 columns, 1 and 2, right? So here we can see that basically the manufacturer is a Chevy, and then we are given some more information about the model of the car. So we're going to learn a little more about how to extract data in different types of ways. So there are 6 different types of ways in which you can index to extract data from R, from a particular data set in R. So we're going to learn about positive integers, how to use negative integers, zeros that are pretty useless actually, and then how to use blank spaces. This is not the Taylor Swift song, or has nothing to do with it, but it is incredible and very useful. This is then we're going to talk about how to use logical values as well as names of columns. Okay, so let's move on and talk about positive integers. So this is the simplest to use. And the one thing to remember is that in R, indexing begins at 1. So if you have been using other types of programs, that's fine. In some of the other programming languages, indexing begins at 0, but not in R. So that's important to remember. And probably a very important point when you're extracting data. Okay, now we already know that R treats positive integers just like ing notation in linear algebra. You just saw that if you write something like, you know, the name of your data followed by square brackets I comma j, then it is going to return the value of the data that is in the ith row and the jth column. Okay, it's best to practice it when you have R opened up rather than just reading through this. And we have also seen that to extract more than one value, we use a vector of positive integers, right? So where in our previous example where we were extracting the 20th to the 22nd row, that was an example of where we were using a vector of positive integers to extract those rows. Now, R's notation system can also be used to select values in any R object as long as you supply one index for each dimension of the object. What does that mean? That means that if you have a vector which is one-dimensional, you are going to supply it one index, okay? If you have a data frame which is two-dimensional, it has rows and it has columns, we need to supply it 2 indexes, right? Something for the row and something for the columns. And similarly, if we have more dimensions, an n-dimensional object, then we need to have n indexes that we would provide R. Okay, so let's take a look at simple examples. Mostly you will be dealing with data that is 2-dimensional. You will have rows and columns, or at least you can always transform your data into rows and columns. So let's, those are the examples that we will cover. So let's take an example here. We want to extract the first row from the MPG dataset along with the first 3 columns, okay? So it's a good idea to always practice different types of commands so you get the hang of this. So we're going to write MPG. We're going to open up our square brackets and we're going to write the number 1, which refers to the first row that we want to extract. And then we want to extract the first 3 columns. So we will write down a vector after that comma, and we are going to then extract the first row and the first 3 columns in that way. So notice here, we get an output which has one row and 3 columns, which is what we expect. And the first 3 columns are manufacturer, model, and displacement. You can take a look at this in your data sets when you're playing around with it. There's another way to do the same type of job, which is to write a sequence of numbers 1 to 3, right, with the colon, which you are now familiar with, instead of writing down a vector here. Okay, that also will give you the same output, but I prefer this way. So, you know, it's sometimes more like if you're making changes to your code, etc., it's easier to write it if you know exactly the number of the column. Okay, now we're going to move on, and we are going to talk about what we said earlier in the previous slide, where we said that you can also subset a vector with just one dimension. So remember that, you know, in our earlier videos, we talked about the vector die, which is just a sequence of numbers from 1 through 6, right? And so if we want to extract the 5th value, and we know what the 5th value is because it's just counting from 1 to 6, we know that the 5th value in the vector die is the number 5, right? So if we open up our square brackets, notice we only need to give it one number because this is a one-dimensional vector. Okay, so that's the difference between looking at some sort of a data frame like MPG, which is 2-dimensional, versus a one-dimensional vector. Okay, let's talk about what happens if we end up repeating the numbers in our call, in our command. Okay, so if we repeat the number in our index, R will return the corresponding values more than once in our subset. So what does this mean? Let's take an example. Let's say we wrote down MPG, and then in the indexing for the row, we repeated the number 1. We gave it a vector, but we repeated the number 1. So what this will do is this type of code will return the first row twice. Okay, so you see here, when you see the output, it's giving you the same row 2 times, okay, because of these numbers being repeated twice. Okay, and because this was only looking at the 3 columns after the comma, then only the 3 columns are displayed here. Okay, you can also apply the same technique to a vector, right? So if I wanted to extract values from die and I wanted to repeat some of those, or a couple of those, for example, here I'm repeating the number 2. So I'm saying extract the second element from die twice over. It's going to repeat that number in the output. Okay. Now it's possible that when you're working with vectors, so if you select 2 or more columns from a data frame, R will return a new data frame. But if you select a single column, it might return a vector. If you want to keep that that output as a data frame, you can just insert a drop equals false argument in that command. Okay, but that's for later. This is sort of a digression, but I just wanted to make sure you know about that. Okay, let's turn to negative integers, right? So these are going to be doing the exact opposite of what positive integers do when we are indexing. Okay, so what negative would mean is that whenever you place a negative sign in front of a vector or a number, R will return every element except the elements in the negative index. Okay, now we'll see how this works, but generally speaking, this provides, using negative integers, provides a more efficient way to subset than positive integers if you want to include the majority of your data frames, rows and columns. Okay, so let's take an example here. It's possible that in your data set, not this data set, but in your data set, it's possible that the first row wasn't adding any value, or the first row had some details on the data, right? And maybe that's not what you need for analysis, right? So what we can do is we can say MPG, open up the square brackets, extract everything but the first row, right? So when we place a negative sign in front of 1, we are saying give me everything but the first row and extract the columns from 1, 2, and 3, right? So that's what it does. And you can see here, obviously I'm using slides, so you can't see the entire thing, but notice that this has, notice the dimensions now. This is important to look at every time you're looking at your output. We had originally 234 rows in our data set, right? And 11 columns. But now that we subtract off 1, we are left with 233 rows, and we only extracted the 3 columns. So we have 3 columns, right? So that's the dimension of this data set. There's another way to extract, although I don't think you'll be using different, it depends on your use case, but really here it's important to know what's going to happen and try to predict, what this command will actually do. So let's say we were writing something like mpg, open up your square brackets, negative sign in front of a sequence from 2 to 234, right? So we're basically saying extract only the first row and get rid of all the rows from the second row all the way to the 234th row, right? And extract the 3 columns. So we can sort of imagine that it's only going to return the first row, right? Only one row will be returned because we don't want everything else, and the first 3 columns. Okay, so this is another way. A third way is to write it as a vector, right? So here, I'm going to switch it up. We are going to use the negative integer on the column index, okay? So here we are extracting the first 5 rows, and then after the comma, we're going to place a negative sign, and we're going to say, don't extract columns 1, 2, 4, and 10, right? So we're excluding columns 1, 2, 4, and 10, and that's why you don't see manufacturer in the first column or the model in the second column, because those 2 are skipped, right? At least those are the ones we remember from before. Okay, so it's very good to practice this and see if you can understand what the dimensions would be. So notice here, here we have the first 5 rows that we are extracting. So obviously this should be the number 5. And then because out of 11 columns or 11 variables that we had, we are getting rid of 4, right? We are putting a minus sign here. So we're getting rid of the 4 columns. And so we're only going to be left with 11 minus 4, which is 7 columns. So that's about positive and negative integers. Let's move on to 0. This is pretty useless in R. It will not return anything if you use zeros for indexing, right? So it's just going to create an empty object, and you can even try this. So if you say mpg square brackets open 0, 0, it's not going to give you anything. Okay, so this is pretty useless, but it's just something to note. Okay, now to blank spaces. Okay, so a blank space tells R to extract every value in a dimension. Okay, it's super useful and works incredibly fast. This is very useful in letting you subset an object on one dimension, but not on the others. So whenever you want to extract all the rows or all the columns from a data frame, that's when you use blank spaces. So let's take a look at the data just to remind ourselves here. So our data set called MPG has 234 rows and 11 columns, okay? And remember that if this is how it's displayed, this is not what it looks like. Remember that the data set, we'll go back to R and just kind of look at our data set that we had seen before. This is showing us that it has 234 rows but 11 columns with all these variables, right? So 11 columns are represented by these column names that you see from manufacturer, model, all the way to class. So it's just good to remember that that's what this is. Okay, so let's go to full screen view and take a look at the example. So if we want to use a blank space, we can do what we were doing before. But if we don't specify any index for rows and we leave a blank space there, we're telling R that we want R to extract all the rows in the 11th column. Why 11th? Because 11 is the number we wrote after the comma, right? So what it does is, if you remember that from the data set, class of the car, of the vehicle, was the 11th column in the data set, or the 11th variable. And so it's going to give us all of the rows associated with that column, okay? We can do that also for columns. So we can use the blank space in columns. Here we are extracting all the columns in the 200th row. Why 200? Because we are writing 200 in the index for the row. Okay, so that's how we use blank spaces. Okay, the next thing is logical values. Okay, now you are pretty familiar with how true and false works in R, and we'll build on this also in other videos. But what R does is R will match each true and false to a row in your data frame or a column, depending on where you place this. Okay. And then it only returns the rows or columns that corresponds to the true values, okay? So one thing to remember, and one really important thing to remember, is for this type of system to work, your vector that you put in the square brackets must be as long as the dimension that you're trying to subset. Let's take an example here. And let's start, with the basics here. So let's not think about MPG for now. Let's think about the vector die, right? Which only took values from 1 to 6, right? And if I wanted to subset die and I wanted to only extract the first and the last values, I would need to supply a vector of 6 trues and falses, right? So the first, if I want to extract the first and the last value, I want to make sure that the first and the last value, the first or the sixth value, right, is true, right? And remember that you don't need to put any quotes around this, because this is true and false. R recognizes whether you write true and false in capital letters or you write true or false in capitals. R recognizes that as a logical command. Okay, so here we are writing true, but for all the other numbers in between, we are writing false. So notice the output here is just 1 and 6, okay? So this type of, you might think, well, in very big data sets, typing so many trues and falses might be inefficient and odd, but these types of concepts will be used to gain efficiency later on. Now, coming back to our data set MPG, let's say we wanted to extract the values from the first row, but only values from columns 1 through 4. Now, obviously, you know how to write this in, extract values using positive integers. But if you were using logical values, then you would have to write number 1 for the first row. But after the comma, you're going to supply R with this entire vector of trues and falses, which will only turn true for the first 4 columns and false otherwise, right? Because we want to only extract the first 4 columns, okay? And then we know that ultimately what the output output that R returns is going to be just 1 would have the dimensions 1 times 4, right? So 1 row and 4 columns, because that's what we wanted to do. So it's given you that. It's given you just the first row, and it's given you the first 4 columns. Okay, so that's how we use logical values. And the final type of indexing that we can do is using the names of the columns themselves. Okay, so you can extract the columns of the data frame if we have names, and usually that it is the case with almost every data set that the columns in your data have some sort of a name. Okay, so let's say we wanted to extract the variables model, year, and highway. So these are the columns we want to extract for the 200th to 201th row. I don't know why I made it so complicated, but anyway, how are we going to write this down? We're going to say MPG, which is our data set, the name of our data set, followed by the square brackets, and in the row indexing, the index for the row, we're going to write down 200 colon 201. You could have even written a vector. We could have written C 200 comma 201. Okay, and then comma, and then after that we're going to use names. Okay, and because these names are character vectors, we want to make sure that those quotes are included in our vector. So this is super important. You can't just write model, year, and highway without the quotes and then run this. That's going to throw an error. So just remember that you can call out the names if those are super easy to remember, and you know, it's not too long also. Okay, so what do we get? We expect that we only extracted 2 rows, so that index should be 2, and then we only extracted 3 columns, so that index, so that dimension should be 3. Okay, so that's what we get here. And if we wanted to extract all the rows for the column named highway, which is just telling us what the highway mileage is for the cars, then we could have done that as well. Okay, so here is the command for that, right? We leave the blank space because we want all of the rows, and we are also using the name. So this is sort of a, you know, it's sort of building on what you have learned. And notice that obviously this doesn't fit into my slides here, but it will be, because we are extracting all rows, this is going to have 234 rows along with just 1 column, which is highway mileage. Okay, now we're going to turn to a second system of notation, which is super useful, using dollar signs. Okay, so how do we use dollar signs? We can extract values using the dollar syntax. Okay, so we're using just the dollar sign that you're familiar with, and we can use that to select a column from any data frame and write the data. So what do we need to do? We want to write the data frame's name and then the column name separated by a dollar sign. So let's go back to R and see how this will function. Okay, for this, you want to make sure that MPG or any kind of other data set that you have is already loaded. And if you know, on line number 4, I'm going to write MPG and then I'm going to put a dollar sign, and notice it's going to tell me all of the variables, all of the column names, right, that were there, right? So over here, I can, let's say, put highway. And if I do that, maybe I don't want this, but what I want to do is, let's just run this. Okay, so it's giving me all these values, right? Obviously by itself, it may not be useful, but what I could do here is I could say, well, in my data set, what is the mean of the highway mileage, right? So that's what I can do. So if I run this, then it gives me an answer. It says 23.4, right? So that's what it's telling me. It's 23.4 miles per gallon. That's the highway mileage. Okay, so those are important things to do. Similarly, you can compute the median, and so you're using different functions and you're combining the power of the dollar sign to get important metrics, right, from your, or to get important insights from your data. So if we wanted to calculate the median of the city mileage, right, we can just use median MPG dollar sign city, and then we get the answer is 17. And obviously if we try to look at what these values are. They intuitive? Well, yes, because we would expect that the highway mileage is more than the city mileage. Okay, now we talked about lists in the previous video, but you can use the same $ notation with the elements of a list if they have names. Okay, so if let's say we designed a list which is called school, right, using the list function here, and it has 3 different elements. It has numbers, right, which is a vector of 3 numbers here. It has some kind of logical value. I don't know what that means. True, it could be false, doesn't matter. You can make any type of list you want. And then it has some fields, right? So econ, stats, and finance. Maybe I put these because they go together so well. Okay, if we want to extract numbers, right, then we can say school $numbers, and it's going to throw these numbers in the output, right? But if I want to sum the elements of the numbers, then I can just put the sum function and put the school $numbers in the parentheses, okay? And that gives you 23, right? Which is the sum of these 3 numbers, okay? So that's sort of how the $ works. Okay, and finally, we're getting to the end of this video. We'll talk about how double brackets work. Now, it's possible that the elements in your list do not have names, okay? So it's possible that, these names that we had before, we don't have these, okay? It's just a list. It's just a list composed of some vectors, some logical values, some other character vectors, etc., right? So in that case, we can subset a list with the double brackets, and R will return the values inside an element of that list. So if we wanted to get all the values from that first element, and notice what the first element is here. The first element is numbers, right? I mean, even though, you don't want to do this with writing the names of these different types of elements, right? So let's just do this in R. So let's say I copy this and I go back to R. Let's say I type this in here, and all I'm saying is, let's say we did not have names for these lists. Let's say we only had, this is what this looks like, okay? So this is what our list looks like. So now school is populated. It's a list of 3 elements. That's what it's telling me, right? So what I can do, I can put school, I can put double brackets, okay? And I can say 1, okay? So let's try to see what that gives us. So notice it's giving me those values, okay? Now I can wrap this and I can say sum of school, double brackets, and 1, okay? So if I ran that, then it gives me 23, right? But if I only use a single bracket, let's say I used a single bracket, it's gonna give me those numbers, but I will not be able to sum those. I'm putting double brackets. I want to put single brackets, and let's say 1. If I tried this, it's gonna say error because it's an invalid type, right? So let's go back to our slides. Okay, so you want to make sure that single bracket, you're not using single brackets when you want to do some sort of computation, because it's going to throw an error when summing or when doing any type of arithmetic. So if you subset a list with single bracket notation, R will return a smaller list. However, you will not be able to do calculations with it. Okay, so you want to use double brackets if you want to extract the elements as it is. Okay, so with that, what have we learned in this video? Now you know how to access values that have been stored in R using R's notation system or its indexing system. What do? We, to extract values or a set of values, we write the name of an object and we usually a data frame or a data set followed by the brackets and indexes. So we're using square brackets and we are using indexation, right? So the important thing to remember is if our object is one-dimensional, like a vector, we only need to supply it one index, like what we did with die. If it's a two-dimensional data frame, right, object like a data frame, then like MPG, then we only need to supply two indexes separated by a comma. And if it's n-dimensional, which we haven't covered, then we need to supply it n indexes, each separated by a comma. Okay, so I hope you found this video useful, and I'll meet you in the next video.